All right, teach more circuits stuff. I think this is homework. Even though sometimes circuit one seems to be a little bit boring, but this is a fascinating field. But just circuit one is the first step of a marathon. So after the first step, you get into microelectronics, digital electronics, embedded systems, FPGAs, even chip design in the future, and you can get into the industry. I know you guys are not in the industry, but if there's a chance you switch to that industry, it's just super fascinating. If you look at the stock market, people are buying stocks and selling stocks. Those stocks are skyrocketed. What are they? Nvidia, ARM, Qualcomm, Apple, all these kind of things. So that's something like dominating this modern society right now. And in order to know how to design or be able to understand what's going on for the Nvidia hardware, okay, which is basically chip design, digital design, chip design, and the first type is circuit one, analog digital logic. So you learn circuit one, you learn digital logic. Basically, you can start learning all the rest of them by yourself, or taking some more lectures. So you can get into that field. A lot of job opportunities in that field. And the tools are available. You can directly download from, just Google it, and just purchase a little digital board. It just costs you $200 and practice it by yourself, or taking a class, and then get a six-digit job, salary job. Shouldn't be that difficult. All right, but we still have to do the boring stuff for this class. I'm so sorry for that. It's laying the groundwork for everything. Dependent source, we didn't talk about that, but you have seen this a lot in the homework assignments. I'm sorry I didn't get a chance to reach that far. Dependent source, if you see something with the what's the name of the shape, whatever, polygon shape, and you got a plus minus in there, and that's a voltage source, dependent voltage source. Because the plus minus is showing a voltage drop, right? If you see a arrow in the middle, so that's a dependent current source. Okay, and there are 4 different types of dependent sources. It could be current dependent current source, current dependent voltage source, voltage dependent current source, current dependent voltage current source. 4 different ones. It's like a tongue twister. But however, it's basically either a voltage dependent voltage source or dependent current source. And what are 4 names? I'm going to write them down one more time. Okay, it could be current dependent current source, could be a voltage dependent current source, or it could be a current dependent voltage source, could be a voltage dependent voltage source. They don't really exist in the real world like a power source. They are basically transistors. But people modeled it this way, put in the circuit one, trying to let students work with them ahead of time. But sometimes it confuses people. We never deal with these dependent source as a benchtop source in the lab. You will never see them in the lab. These are just models of transistors in the future. If you take microelectronics in the future, these are current dependent voltage source or voltage dependent current source, depending on the type of transistor. So just let you guys know, these are not real benchtop equipment that you can usually use, right? So it's just people just put in the problems to confuse you guys and scare you, test you. If you don't like it, don't get into this field. And let me label this. It's alpha IX. So let me know which one it is. So it's a C. Sometimes they use dependent, sometimes they use controlled. you know, so it interchangeable. You can use controlled or dependent.
Is it a current dependent voltage source?
This one?
Yeah.
Yes. Because the current is a variable, and this is the voltage source, right? So for short, for all the names, you can sometimes you can see CCS, right? Current control, current source. Voltage controlled current source. Current controlled voltage source, or voltage controlled voltage source. 4 names, okay, 4 names. And this one is definitely current controlled voltage source. And the current source showing the branch current, which is 7 amps. And this one, it tells you the voltage, which is the voltage across the current source here, which is 4.25 volts. And it tells you the current here is 5.5 amps. And asking you to calculate alpha. How do you solve it? How to solve for alpha? KCL, right? You know the currents and the node. Definitely, you can just label all the currents flowing in and flowing out from the node. So 5.5 amps. This is just the ideal source, current source. If it tells you it's going to be 5.5 amps, doesn't matter what the voltage across it. So the branch current will be 5.5 amps for sure, right? Keep that in mind. 7 amps. No doubt, because it tells you it's 7 amps. Always trust it. 7 amps. Doesn't matter what kind of voltage source in the branch. If it shows you it's a current source and 7 amps, it's going to push it. It's going to push the whole branch flowing a 7 amp current into it. So it's flowing into this node with that 7 amps. So your node 2 currents are just 3 branches connecting to the node, and you already know 2 of them. Could you know this one? Yes. Depending on how you labeled it, right? So what's the current flowing into it? It didn't tell you, right? So if I label it that way, what's the current flowing down? 7 minus 5.5, right? Because 1 going in, 2 going out. So the current going in equals the summation of the 2 going out. So that's why you know this one. So this is just 7 minus 5.5. It's 1.5 amps, right? Is it good enough to calculate alpha? What is Ix? What is Ix? Oh, Ix is here. It labeled Ix like that way. It's Ix. Sorry. Ix flowing right to the left. So what is Ix? Yes. What is the voltage across it? What's the voltage here? It's given, right? It tells you the voltage across this 2 terminals of the current source is 4.25 volts. Okay, 4.25 volts. Same wire, same voltage. 4.25 volts. 4.25 volts. No difference. Same metal piece. So the metal conduct voltage, right? There's no resistor in the middle, so there's no drop. Keep in mind, no resistor, no drop. No component, no other component, just a wire, same voltage everywhere. 4.25 volts, 4.25 volts, right? So this is the voltage source. This is the voltage source. Plus minus. So plus minus 4.25 volts, plus minus 4.25 volts. Is that correct? So alpha Ix equals what? Because that's the voltage value of this voltage source. It's a current dependent voltage source. So alpha Ix is a voltage across this dependent source. Plus minus. So this equals 4.25 volts. Do you know Ix? Yes. Given. So what is alpha? 4.25 divided by minus 5.5 amps. Just calculate it for that value. Okay? Another problem.
Should it be a minus 1.5 amps?
Ix is what?
Because there's 1.5 amps. Current.
Yeah, we didn't use it. I calculated, but we didn't use it. This problem didn't even reach there.
What is alpha resistance from? The resistance?
It's just a parameter.
Oh.
Nobody cares. It's just a parameter. It's ask you to calculate the parameter. You don't care about that. Yeah, it's a waste of time. Any questions?
Why are we using the 5.5 amps? 1.5 is the thing that's flowing through the variable voltage supply.
Because it depends on Ix, but not this current.
So is 5.5 labeled as IX earlier?
Yes, this is given, actually.
Okay.
I think that's what's on the problem. Yeah, it's labeled Ix flowing that way. So the voltage source here depends on the current flow that way. Times R alpha. Okay? 5.5 amps is given because this current source is given. Right? Current source is given. Yeah, that's right.
So the dependent sources depend on the current of a different component.
Yes.
5 volts.
Yeah. So you can see all these different problems, the dependent sources, they depends on all different kinds of values. Could be a resistor's voltage, could be a current. They just made it up.
So you just specified some arbitrary constraint what the out of the way that component works.
Yeah, it depends on what the problem tells you.
Okay.
If they tells you it's alpha Ix, you just have to find out where's Ix first. Okay? Like I said, a lot of times they probably don't make any sense because they just made it up. Alright? Just want to let you know it depends on something. And practice your like Ohm's law, KCL, KVL skills. That's it. There won't be anything like having a voltage source depends on current flowing that way most of the time. But you do have dependent sources as in the future. If you take advanced circuits, there will be transistors, the voltage or the current cross it depends on the voltage somewhere else. It happens. But not these specific cases. Sometimes they have a current here but have a voltage super far away from it, and it depends on that little resistor's voltage drop. It doesn't make sense. It's just a model. It just tells you how to deal with it. Any other questions? Cool. Great. I like you ask questions. You ask questions, you help other people as well at the same time. It's good. Another circuit. Hopefully these examples, simple examples, will solve a lot of problems with other similar problems in the homework assignments. This is another one. You'll let me know what this is. In a double ease way. What is this guy? Something controls something source, right? What is that? What is it? It's a voltage controlled voltage source. How could you tell? Plus minus is the voltage source. There's no arrow in the middle, so it's a voltage source, definitely. And it's a Vx controlled, so it's a voltage controlled voltage source. And this is a Vx. So actually the voltage across this resistor controls the voltage value of this voltage source. So you have to know what is this first before you know the voltage here. R1, I think the problem tells you R1 is 19.4 ohms. R2, 3.2 ohms. Alpha, 0.35 something. That's drop across the current source is labeled as VL. And the I is also given, which is 5 amps going up. So it's asking you to calculate VO. Could you do that? Where do we start with? Look at the current. It's just one branch. So it becomes super simple. Just one branch, 5 amps. It's 5 amps everywhere. Doesn't matter if you have what kind of voltage sources. It's going to force the current in this whole loop to be 5 amps no matter what. So according to Ohm's law, current flows through a resistor. You're getting a what? Voltage drop. All right. So what's the drop here? Let's say VR1. So what is VR1? It's I times what? R1, which is 5 amps times 19.4. And what is Vx? Vx is 5 amps times 3.2 ohms. What is alpha? This. So what's the voltage here? You can definitely calculate it, right? Given, calculate it. So you know the voltage across it. Know the voltage across it. Okay? So how to calculate VO though? Since you know the drops here, 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 use which law? KVL. It's a loop. You have a little guy here, travel clockwise through the circuit. If you see a minus sign, just put a minus sign in front of that voltage. If you see a plus sign, put a plus sign in front of that voltage. And you add them together, you're getting a 0, right? So now let's start traveling. So what's the first one? Tell me, what's the first one? What's the negative what? V0, right? That's the voltage here across this component. And then next, what's next? Plus or minus? It's gonna see a plus first. A plus. Plus what? It's right here, VR1. Definitely it's calculated, right? What's the next? Also a plus. So plus what? It's a Vx, right? Vx. So plus Vx. It's also calculated. You can calculate it here. I just didn't put a number here. And what's next? Plus or minus? Minus. Minus what? Alpha Vx, right? Vx is right to calculate. Alpha is given. Definitely you can find out alpha Vx equals what? 0. So if you move this guy to here, you're getting V0 equals all these kind of things, right? Any questions about this problem?
Could you repeat again how you find the polarity of a resistor if it's unlabeled?
Polarity of the resistor, because the current is flowing from left to right. Okay? If the current flowing from left to right, the drop is going to from left to right. Okay? It flows from here to here. And it's going to cause the drop from here to here. If it flows backwards, it's going to cause the drop from here to here. A positive drop. That's what I'm talking about. Positive drop. So current, it forces the current in the branch to be 5 amps flow going up. Okay? So that's why it's dropping from here to here to here to here. So it brings up another issue I want to talk about. So for example, here's a battery. It has plus minus, right? And here's a resistor. The plus minus. So student asks a question: How do you determine the current? For example, these are all positive voltage drops from here to here. 1.5 volts. This is 1.5 volts. These are definitely two different components, right? One is the battery, it's an active component. Another one is a passive. It's just in black box, right? However, by default, if there's nothing else pushing things around, we just make a very simple circuit. And let's just short it. I know it's gonna burn it, but let's just short it. Make it simple, all right? Make a loop. So they are both plus minus and plus minus. Why this guy is pushing current out and why this guy is flowing current from top to bottom? How do you know that? What's the difference?
They both hold or create some type of difference in your potential voltages. Your battery will just step up whatever your negative terminal voltage is by 1.5 volts, where your resistor will block your high potential from the top side from flowing down to the bottom side. So if you short it like you did, there will be a high potential in the positive terminal and a low potential in the negative terminal, and it won't flow that way.
But why this one is not flowing that way, flowing down?
Because the battery is stepping up the potential voltage from whatever the negative terminal is, just straight up
because of some sort of chemical reaction inside, right? So the chemical reaction separates the charges. That's what the battery does. However, this is a passive component. It doesn't have that kind of energy inside. So it's just a plus minus has a potential difference. It's going to flow current from top to bottom. It's a higher potential flowing to the lower potential. For here, the chemical reaction does all the magic and separate the charges. So it's going to flow current the other way. And this is just a wire. It's a low resistance. So the charges, as the current want to go to the shortcut. So it's going to go that way and come back to the cathode.
For both of these cases, the current going in and coming out is going to be the same, right?
For the power analysis,
Yeah.
right? Yes. So for power analysis, if you see this one going out or this one going out, doesn't matter what component you have, they are. So what we say is if they're going out, right? So it's either developing or delivering or what? Is there another term about that? Let's just use these two first, okay? So it's developing or delivering power, right? So you'll see developing a lot in the homework assignments. So it's developing power because it's sending power, sending current out, it's pushing current out. If it's going out, if it's going into the minus terminal, it's called dissipating or absorbing, right? Doesn't matter if it's an active or passive component. Any questions? Any other questions? It's just for specific problems or questions. You deal with it. You use a different way. Let me grab another problem. Did we solve this problem? We did, right? Okay. Okay, this one. This one. 10 volts, 6 volts, 24 volts, and 40 milliamps. It's asking, oh, we already did it, did we? We haven't. I think, let's see, what's the question? So total power developed by the circuit, total power. Developed. So you have to find out like the components, right? Components that we had for the homework one. There's a model. We have to, if it's giving a negative voltage, we flip it. Remember, the only one rule want to apply to all these cases to be fine for all the cases. If it's giving a negative voltage, we'll flip it, right? If it's giving a negative current, we flip it. So we know the real voltage and current applied to the circuit first. So we have to convert it to this case and then look at if the current is going in or going out to know if it's developing. Developed means it's sending, right? Developed or supplied. Just different terminology. Supplied. So it's actually going out. It's going out. It's going out. Okay? Let's see which one is absorbing, which one is developing. If it tells you there's a 40 milliamps current flowing from right to left, should you trust it? You just trust it, right? So it's going to be a current flowing that way and coming back forever for 40 milliamps. Doesn't matter what kind of voltage source you have in the circuit. But do you know the voltage across it? We can definitely calculate it, but now it's not given. Okay? So this is a 10 volts. It's a positive voltage source. So the current is going in. Is absorbing or developing? Is this one absorbing or developing? Absorbing. So it's not sending out current from the anode, right? So it's actually absorbing. So we just ignore it because it's not asking you to calculate the absorbed. It's just developed. What about this one? Absorbing as well, right? What about this guy? developing. So we know the voltage, we know the current. So we get the first power. And we're gonna add to this one and see if this one is developing or absorbing, right? How could we tell? How can we tell if it's developing or absorbing? We have to figure out if I label it as plus minus, if this is the positive voltage or negative voltage. And if I label it as plus minus, if it's a negative voltage, I have to flip it, right? So now let's see what's the voltage across it. What's the voltage across it? This is 24 volts. It's 24 volts plus minus 24 volts, right? And you put the two batteries in series, they are basically adding up the voltage. Why? Because it's from, for example, you take this as a reference. Okay? So voltage here to here is being boosted by the battery by 6 volts, right? And then from here to here is being boosted by another time, boost again by 10 volts. So basically from here to here you are getting 16 volts. These two terminals, right? These two terminals, you are getting 16 volts difference between these two nodes. So let's take the same baseline for this voltage source. What's the voltage across these 2 points for this, in this case? 24 volts. Same baseline. Now you see a ground pin here, right? So it's good to have a same reference. So now I have the same baseline, so I don't care about this point anymore. Don't get confused. A lot of times you are getting confused about like the node voltage, the relative value of the voltage, the comparison, the subtraction. It's getting things complicated. Now, since this is recorded, next time you're getting confused, just come back to this video. See how I do the problem. You find the same baseline, okay? And here, 16 volts, and here, 6 volts and 16 volts. That's the 16 volts difference. From here to here, 24 volts difference, okay? If I use the same baseline, I'm just looking at the node voltage. Which one's higher? Which one's higher? Which node is higher? This is higher, right? So which means this node has a higher potential compared to here. If we compare to the same baseline, this one has a higher potential definitely. What's gonna happen? Higher potential is gonna do what? It's gonna drop from here to here, right? So what does that mean? So when it drops, so what you wanna label? How do you wanna label it? Plus or minus, right? So it's actually not as what I labeled previously. So it's actually plus minus. It's dropping that way. By what? By 8 volts. So the voltage across the current sources from right to left is dropping 8 volts. Okay? So the current is flowing in. So it's definitely not developing, it's absorbing. So the only one developing power is just this guy, which is this. You may have different numbers for your homework assignment because it's randomizing all the numbers. It's picking up a random number for the problem. So it may be a different number, different values. However, this is how to do the problem. If you know how to do it, it should, if you plug in different numbers, it should apply to that as well. Any questions about this? Good? Okay. Got a new paper. V delta. Let me know what this source is. What's the name of that source? Yep. It's a voltage dependent or voltage controlled current source. Voltage controlled current source. Current controlled current source. Voltage control current source. Voltage control current source. So what's the voltage here? It's voltage across the current source, right? So it's asking you what's the power developed by the circuit. So I have to figure out which one is developing. Voltage developed by the circuit. Where to start with? Yeah, still look at the current source first. So you can use KCL. 70 amps, no matter what you have in the branch, it's gonna give you 70 amps. You have to trust it. Just trust it. 25 amps, 25 amps. Right? Because this is pointing up, let's just make our life easier. Let's just label that current going up. Right? So what is that current? So you have 70 amps going out, but 2 currents going in. So 5 V delta is basically 70 minus 25, which is 45. 45 amps. What's next? So because it's asking you the power developed, so you want to know the polarity of the voltages and currents. It's basically asking to solve the circuit. Sometimes you'll see this a lot. Solve the circuit. So you are solving all the voltages and currents of every single component in the circuit, so you'll know what's going on for the circuit. So it's asking you to solve the circuit. Now we know the current here is 45 amps. So 45 amps going up. So this is definitely ignored, right? It's just absorbing. You don't have to worry about that. Right? So what is delta V delta? What is V delta? 9, yeah. 45 over 5, which is 9 volts. So plus minus 9 volts, right? Okay, so it's going in to the cathode and coming out from the anode, even though it's not the voltage source. However, this source is developing or absorbing. Developing, right? Because it's going out from the anode. All right. So now you got a P1, which is this guy. It's going to be 9 volts times what? 25 amps. That's the first power you have. Now let's look at this one. Since we know 5 delta V, but however 5 delta V is a current, not a voltage, because it's a current. It's a voltage control current source, right? So when you get this number, it's giving you the current. But do you know the voltage across it? Not yet. How can we calculate it? It's 9 volts here. So let's see if you guys can get it. No, in the future you will, but now let's see. So it's 9 volts here, right? It's 9 volts here. 9 volts here, no problem. Okay. If we ground it, it's okay. Just set a reference. It's based just depending on like if it's like 10 minus 1 or 9 minus 0. It's the same thing. Let's just see. This is 9 minus 0. 9 minus 0. Okay, across it. 9 minus 0. It's giving you 9 volts drop. Or you want to say, hey, I don't want this to be 0 volts. I just want this to be 1 volt. It's okay. It's okay. So if this is 1 volt, it's getting boosted by 9 volts. What's the voltage here? 10. It's the same thing. It's just relative, right? It's all difference. If you can use 0, if you can use 1, you can even use 1,000. Who cares? So can I start this at 0? Yes. Right? Can I? Yeah, just easier because something minus 0 is still something. It's easier to calculate. Okay? Yeah, you can ground anywhere in the circuit. You can ground anything. You can ground anywhere in the circuit. Now, I ground it, no problem, right? Like what I just explained, no problem. I ground it, okay? 9 volts difference. What's the voltage here? 0 volts. What's the power? What's the voltage source? 20 volts. So this 0 volts will be decreased or boosted by 20 volts by the power supply. From plus minus, it's going to be decreased by 20 volts. So you have 0 volts here, decreased by 20 volts. What's the voltage here? Negative 20 volts, right? Compared to where? Compared to grounds. Compared to grounds, negative 20 volts. What's the voltage here? 9 volts compared to ground. So what's the voltage across it? Positive 29 volts. So you got an anode, current flowing out from anode. Is this guy developing or absorbing? Developing. So it's current flowing out from anode. It's developing. So we get another power we'll have to calculate into the equation. So this is what? 29 volts times what? What's 45 amps, right? We got another one. All right. 70 amps. Should we trust it? Yes. Flowing that way. Is this developing or absorbing? Developing or absorbing? Absorbing. Only one left. What's the voltage across it? What's the voltage across it here? 9. What's the voltage here? What's the voltage here? 9 volts being boosted or decreased. Decreased by what? What's the voltage here compared to ground?
41, negative 41.
Yep. Which is plus, which is minus? Yep. Current flowing out or in of the black box? Out. So we got a P3. What is P3? Yeah? Just P1 plus P2 plus P3. P, just adding them together, right? So that's all the P's developed. Devil. Devil P. P developed, okay? P dev. Any questions? Anything? Hard? Okay. Level? Right. Well, let's see, no problem. This one asks you to calculate this guy is 65 volts. It's 20 ohms, 30 ohms, 15 ohms, 15 ohms. Ask you to calculate power dissipated in each resistor. Dissipated. So dissipated is what? Absorbed. Because it's absorb that current and dissipate as a heat. Right? So you see the heating component of the circuit printers on the back, right? So it's heating up the filament to keep it soft, I think. And also heaters of the car seat, okay? And the heater of the freezer. Have you heard about that? You probably didn't know that, okay? If you become a homeowner, you have to deal with all this kind of SHIT. So since I have to fix everything in my house, it's not too old, built in 2005, but I probably have fixed the freezer, the washing machine, the dryer, the HVAC, the water heater. What else I fixed? So many things. Oh my goodness. So I discovered that the freezer has a heater inside. Can't believe that. The heater is a low resistance resistor, usually 20 ohms. And it's just a resistor, just a metal bar. And it heats it up to melt the ice building on the back of the freezer. But you are thinking like, it's heating up, how do you still get the temperature down to like minus 20 Celsius degree? It's not affecting it because the heater is just heating locally, just melting the ice, but not something else. You're still getting minus 20 Celsius degree inside. It's not always turned on because it's just whenever it builds up the ice, there's a little temperature sensor, sense it, will trigger that little mechanical switch and turn on the heater. So it's just running a current through a low resistor. So you'll know it's a heavy load, right? So the low resistance is a heavy load because heating up, becoming red. It's hot red resistor. So it's generating heat, but only 20 ohms. If you put a like 10 mega ohm resistor in there, can you still heat up things efficiently? No, you're not getting enough current because that 1 mega ohm will reduce the current significantly. Unless you are applying like 20,000 volts from the power plant directly. It's gonna consume a lot of power. So it's low resistance, maybe just 110 volts will directly burn it and to melt ice in the freezer. Anyway, so power absorbed. Where to start with? Definitely we can use KCL, but I just don't want to spend the time on that. Let's just deal with it the way that I've been looking at how I look at it. So for example, you have parallel resistors because we have to teach this for tutorial 4 and homework 4 anyway. You got R1, R2, right? So if you have a person standing here looking into it, and the two terminals, so this is a black box. So this black box, you can treat it as one equivalent resistor. So what that resistance is, you have learned that in physics. However, how do we calculate it? So across the two terminals, there's got a V, right? Because it's the same metal, so we're getting the same V here and here for the two branches, for the parallel resistors. Okay? Because the entire resistors are equivalent, so V over R equivalent is the overall I flowing into the two branches, and it's getting into two branches, but still the same current. So the current can split into the two branches. So these two current, if you add them together, it should be the same I. So this is the overall I, and you get the first I, which is I1, which is V over R1, and the second I, which is V over R2, right? And then you cancel out V. I'm getting 1 here. So R equivalent eventually equals 1 over R1 plus 1 over R2, which is R1 times R2 over R1 plus R2. That's the parallel resistance for the two resistors. So if you look at this circuit, which ones are in parallel? So in series, you add them together, right? So the resistors, you get 1 ohm, got another one, so 1 ohm, 1 ohm. So the overall resistance will be 2 ohms. You'll learn that in physics, right? So now in parallel, I have to use this equation to calculate the resistance, equivalent resistance. So now let's do it. 30 ohms, 15 ohms. So the equivalent resistance of these two components in parallel, which is 30 times 15 over 30 plus 15, which is what? 450 over 45, which is 10 ohms. It's 10 ohms. So you can convert the circuit into this. 10 ohms, 20 ohms, 65 volts. Now it becomes easier, since we can directly calculate the current here, which is I equals 65 over 20 plus 10, which is 2.1 something amps. So you know the current flowing here is 2.1 amps. Okay? Because you don't have other components, this is the only source. So it's gonna push it. Definitely it's gonna push it that way. So we're getting plus minus because it's dropping that way. It's definitely gonna push down as well. So it's plus minus for sure. Okay? So all of them are absorbing. It's just one source pushing into it. Right? So now I got the overall current by doing this. What's next? Do you know the voltage across it? Not yet. You know the voltage here, but not the voltage here. So how do you get the voltage here? Is it a voltage drop, right? So this is 65 volts, dropped by something. So you can get a voltage here, right? So what's the drop here? So that's VRG, right? What is it? 2.1 amps times this guy, which is 22 volts. Could this drop bigger than this? Is that possible? Can the drop here bigger than the source? In this circuit. Is that possible? Just in this circuit. Is that possible? No other sources. Just one source. It's impossible because you got a 1 voltage source, it dropped, comes back at 0. So it's a positive number being dropped twice, becomes 0. So it's dividing that voltage into 2 positive voltages. They are passive components, not active, not adding something. It's just dropping, all right? So 65 volts dropped by 22 volts. What's the voltage here compared to ground? If I ground it, what's the voltage here? 65 volts dropped by 22 volts. What's the voltage here? 43 volts, right? Oh, what's up?
The first voltage drop, 2.1 times 20, 42 volts drop.
Oh, yeah, 42. Thank you. 42 volts. Yeah, 42 volts, yes. So 65 minus 42, you're getting 23 volts. So that's the 23 volts here, right? 23 volts here as well. You got the voltages for the resistors. Can I get a current? Yes, Ohm's law. Voltage divided by resistor, you get a current. So now you got a voltage, you got a current. You can calculate the power. Is that clear? Any questions about this? Yeah, you need more practice on this type of problem. Since this is due Friday. Wait, is this due Friday? Okay, see you on start of Wednesday. Good luck with it. Sure, we can go over there. Let me, yeah.
Can I go to any tutorial or office hours?
Okay, sure, no problem.